All right, I'm going to go to video 2, and I'm going to work more examples. So here are the next examples, y'all. There are multiple ways. Once you learn the rules, there'll be multiple ways you can solve each of these problems. But let's check out this one. This is number 5. It says 4 to the b0 times 3b to the 1/3. So this is multiplying. So we're going to go to 4 times 3, which is 12. And then you have to add the exponents. So we know we have a b. Here's the fun part. What's 0 plus 1/3? 0 plus 1/3 is just 1/3. So you're good there. You could also have solved this a different way. You could have been like, hey, check it out. I know that b to the 0 ends up being 1. So I'm going to evaluate that first, and then I'm just going to have this to write down. And then when you do it like this way, then you can just see 4 times 3 is 12, and then you just keep the b to the 1/3. Both ways are valid. All right, let's talk about this one right here. We have 3 to the 0 with x to the 2/5 times 8x to the 0. All right, I think I'm going to solve this by clearing my zeros first. I think this is a kooky enough example that, yeah, I'm going to get rid of my zeros. 3 to the 0, remember, anything raised to the power of 0 is 1. So I'll write the 1 in there, but it's not necessary, but I'll do it so we don't see it disappear and freak out. So that just says a 1 right there. Now, x to the 0 is also a 1. Do we need to write 8 times 1, or can I just write 8 and everyone will be cool with that? I hope so. All right, now let's do this. We have to multiply our numbers together. Technically, there's a 1 in front of that x, so there's an 8. And then my x 2 to the 5th just stays. So it depends on how you want to work it. That's the easiest way. If I see 2 zeros, I'm clearing those zeros as quick as possible. Number 7. Now we're dealing with the rule of subtracting. Remember the rule for division. When it has a base on top and a base on bottom, the numerator and denominator, you have to subtract. So you go 5/8 minus 1/4. Now, you have to have common denominators. The best way to do this, on this one, to find the common denominator, it's easy. You can tell that it's 8. So I'm going to make this common denominator 8. From 4 to 8, I multiplied by 2. So I'm going to multiply the top one by 2 as well. And then I kept this one the same. So I end up with that for my fractions, 5/8 minus 2/8. And the rules for subtraction fractions are keep the denominator and then subtract the numerator. So 5 minus 2 is 3/8. So when this is done, you write x to the 3/8. Boom. And that's your answer. All right, going to the next one. When I see a problem like this, I'm going to draw my fraction bar because I have to solve the numbers first. 4 over 16. That can reduce, y'all. 4 over 16 can reduce to 1 over 4. So I'm going to go ahead and write this down on my fraction. This is my first setup. And then I have to subtract my variables. I have 1/3 minus 4/9. I have 1/3 minus 4 over 9. 1/3 minus 4 over 9. It's the top minus the bottom. Now, I got to get a common denominator. The common denominator for this is 9. Again, if you're struck on like, oh my God, how did I do that? Y'all, like, I don't know how many more times I got to teach fractions. Like, y'all need to figure this out. From 3 to 9, I multiplied by 3. So I'm going to multiply the top part by 3 as well. So that ends up changing to 3/9, and then the 4/9 stays the same. So now remember the rules. The rules are you subtract. So 3/9 minus 4/9 is equal to negative 1/9. Now we'll clean it up on the next one. But since it's when you're done with this process, always put it in the numerator no matter what. Always put it in the numerator no matter what. And then you can clean it up on the next round. So let's ask ourselves, do we like negative exponents? We don't. So we know there's a 1 up here. We know there's a 4 down here. And then this has got to move down to the bottom. And when it does, it switches to a positive exponent. And now you are at your answer. So that's how you do that one. Let me go down to more problems. I want to solve all the problems today. Check out number 9. This is dealing with negative exponents. Again, the rule is the same. This is a division. So you're going to have minus 4 minus, which is part of the division rule, and then I have that negative number, negative 3. Remember when we have a minus minus, that's going to turn into a plus. So negative 4 plus 3 ends up being negative 1. So we write our answer as x to the negative 1. It always goes on top. But remember, we don't like negative exponents, so we're going to move it. And then that ends up being your answer. You don't have to write the 1 to the x, or x to the 1 power. You can write it like this. But that's just to let y'all know what's going on. All right, check out number 10. We're going to have the same thing. We're going to end up with an x on top and a y on top for our first step. If we end up with negative fractions, our negative numbers, we'll end up moving them as we need to. But let's start with this. 3/5 minus 4/5. 3/5 minus 4/5. And the rule is, if the denominator is the same, you're ready to go. So our denominator is the same. 3 minus 4 is negative 1. So I have for my x, I have negative 1/5, which we'll fix on the next step. Then my y. I have 3/4 minus negative 3/4. So let's look at this. 3/4 is here. Minus is part of what I have to do when it's division. And then there's a negative 3/4 right there. So make sure you watch your negative signs. There's no leeway for this. There's no oopsies on these problems. They're either right or they're wrong. So 3/4 minus minus ends up being plus plus. Keep the denominator. And 3 plus 3 is 6. And then can we simplify it? You can divide both of these numbers by 2. So then I end up with 3/2. So I end up with 3/2 for my exponent here. But now I got to clean it up. The y can stay in the numerator because it's positive. But I got to move this sucker down because it needs to go and turn positive. And that's our answer for number 10. Moving on to the last examples. Here we go. This rule is on your list, and this is kind of a difficult one to do. My recommendation when you see a problem like this, when you have a bunch of stuff inside, I would recommend solving the interior of the parentheses first and then worrying about the exponent. So let's take this out. Let's see what we got here. 50 divided by 2 is 25. So I know 25 is going to be there. I have a 1 right here and a 1 right here, which following our old rules, if we were doing our old math, we know x and x just cancels out. But this is y, because when you subtract the exponents, you end up with x to the 0, which ends up being 1. So this just goes away. This just cancels out, and you end up with 25 to the negative 1/2. Now, how do you make this work the way you want it to work? All right, here it goes. You basically are going to keep it just like this. All right, we know we don't like having negative exponents, so when you evaluate this, what you end up with is 25 to the negative 1/2, which there's another lecture that's going to talk about how to turn this into the proper square root thing, but we're not there yet. So we know to get rid of the negative exponent, we got to flip it down to the denominator. Or if it was on the denominator, flip it to the numerator, right? Just flip sides. So this is going to be shoved down. So it's going to be 25 to the 1/2. And again, you can leave it like this for now. And what's remaining up here is a 1. So now let's talk about problem 12. If I were y'all, I would simplify problem 12, the interior of the parentheses first. 81 divided by 3, what does that come out to? 27. So I'm going to end up with 27 right here. And then I'm going to combine my x's. So the x's right here, these are x, here's an x. 4 minus, because that's the operation, and then this is a negative 2, minus 2. Turn that into a positive, and you end up with a 6. So I end up with 27x to the 6th raised to the power of negative 1/3. Now, this is where it gets a little weird. This is where it gets a little bizarre. You now have to take this exponent, and you're going to basically apply it to every single thing inside. So it breaks apart like this. You get 27 to the negative 1/3. That's one term that you get from this. And then you're going to get x to the 6th to the negative 1/3. Now, what's the rule when you have a power raised to a power? A power raised to a power, you multiply. So you see how we're going to be multiplying fractions here? This one right here, technically this number evaluates down to like a 1/3, but we're not there yet. I'm not going to teach you that yet today. So this is perfectly fine now, but this is what you have to figure out with your exponents. It's 6 times negative 1 to the 3rd. So how do I do that? 6 over 1 times negative 1/3. That's how you do it. Multiplication is the easy for fractions. You just do straight across, straight across. 6 times negative 1 is negative 6. 1 times 3 is 3. This divides out to be negative 2. So when I multiply 6 times negative 1/3, it comes out to be negative 2. So let me push pause and move that. Hold on. All right, I moved that to give me a little bit more workspace. Now I'm going to come back and finish this. Okay, so I know that my exponent was negative 2 for my x. So I'm going to write this down what I got. I have 27 to the negative 1/3, which we'll deal with later, times x to the negative 2, times x to the negative 2. Now, we don't like negative exponents, so let's fix that. This goes to 27 to the 1/3. And then x squared goes on the bottom. And then I have a 1 on top. So it builds in complexity, obviously. That's how we go. And then this 27 to 1/3 can actually be rewritten into something else. But we touched on that last week. We'll touch on it again later in the week. So that's basically what we have for our examples today. This is showing you how to do your fractions, how to reduce them, things like that. I also included a YouTube video on this, and the best way to get this, honestly, is to just do the work, guys. So there is a worksheet that's due. Yeah, good luck.